Hi class, this is lesson 29 and this is our science section. Today we're going to be learning about waves as we continue our study of oceanography. And so we have a worksheet. I'm going to be giving you some information from the worksheet as well, but let's go ahead and take some notes. So go ahead and put today's date down and we'll look in our science notes section now and you can copy these notes. Let's think about for a minute. Waves are things that we see on the coastline. We see them even out in the middle of the ocean. So the cause of waves is wind. Okay, so the wind blows on the surface of the water and it causes a wave to form. Now the thing about a wave is not carrying water forward. I know it kind of looks that way, but it actually doesn't. The water does not actually move forward. There's an energy of the wind that moves along the surface, and what it does is each particle of the wave, each molecule of the water in the wave moves in a circular motion. So what happens is, and I'm going to draw this on your page, is that you have the surface of the water, which I'm drawing across this section here, and then the wind comes down on it. And the wind kind of stirs the top of the water, and what happens is a wave begins to form. The water begins moving like this. And so what happens is the water molecules form this wave, and they begin moving. The water molecule begins moving in a circle as the wave lifts it, and then it carries it down, and then it comes down. So there's a circular motion. Anywhere on this wave, this wave diagram, the wave begins moving the particle, and it moves in a circular motion. And so the net result is, even though it moves forward a little bit, it moves backward. And so the net movement is right where it started. So the particle moves forward and then comes back as the wave passes through. So it lifts the particle and it lowers the particle. And the net result is there is no forward movement, but a wave passes through, okay? And so that's kind of an interesting thing. You would think that the wave is moving forward. It really doesn't. It just kind of appears that way. So there are two parts of a wave, and we can look at the wave and kind of evaluate. And it's kind of always changing as a wave moves, a wave length moves. And so energy is transferred, but there's no net movement of the water. So the two parts. The first is the crest, and the crest would be the high point on a wave. And then there's a trough. The trough is the low point. It's kind of in the valley of the wave. So if we have this wave that looks like this, we've got a crest here on the top of each of these, and then we have a valley here, and this would be the trough down here on the bottom. Now, the distance from one crest to the other crest is the wavelength. So I want to write that down. The distance and this is how you would measure a wave, is the distance from crest to crest would be one wavelength. This equals one wavelength. And of course we have really long waves and we have short little waves. And the short waves indicate a lot of energy, making those wavelengths very short. This is a pretty long wavelength as you look at it from crest to crest. That's kind of a long wavelength. Now you could also measure it from trough to trough. So if you measure that same distance, and you know what? It's going to be the same distance. This distance A is the same as this distance B. Okay, so a wavelength is from crest to crest. It's one wavelength, or it could be from trough to trough. Doesn't matter. It's going to be the same. And this symbol for a wavelength is lambda. It's the Greek symbol. Looks like an upside down Y. Lambda. Okay? Lambda is a symbol for one wavelength. So you're going to have a really short lambda if it's a tight wave. So if it's like this little wave, you can see that's going to be a very short lambda. It's going to be a very short wavelength. The longer wavelength, like we see in this upper diagram, is much longer. The short wavelength is indicative of high energy. And likewise, a long wavelength means there's really low energy. So out in the middle of the ocean, you might see these big rolling waves. We would call them swells. And there's not a lot of energy there. It's pretty calm, but it lifts a boat, and then the boat goes down, and as the wave goes past, the boat goes up, and then it goes down, and it goes back up. And but if you saw this little boat for these little tiny wavelengths, it's going to lift the boat, set it down, lift it. It's going to be rather fast as the wave goes by. And it's going to pick it up and down, up and up and down. That boat's going to go up. And so you can kind of see how that short wavelength is transmitting a great deal of energy. Now, when we talk about the height of a wave, this would be the distance from the crest all the way to the distance or to the place of the trough. So if you measure this little distance here as you find the top, the crest line, you measure this distance from the crest down to the trough. There you've got the height. So there's different kinds of waves that we can catalog as well, kinds of waves. One type of wave, or one kind of wave, is the surf. And we're going to go through, we're just going to list these, and then we'll define each. We also have whitecaps. Whitecaps. And again, you can see that would be the waves with this foam on the top. Then we've got what are called breakers. And these all have to do with wave action. So let's define each one. So let's take a look at these kinds of waves. There's the surf, which is where you have a loud wave that crashes on the shore. So we're familiar with the surf. People go surfing in the surf as that wave crashes. If you're on a surfboard, or if you're just with your body on top of the wave, it'll push you forward. Now the wave doesn't push forward, but the surf carries you forward. Remember, a wave, the particles just go up and down. They move in a circular fashion, but there's no net movement forward. Now, number 2, we have whitecaps. And here's where a strong wind pushes water off the top. So we have water that's being pushed off the top of the wave because of a strong wind. So you'll see little foamy whitecaps in a storm condition. So you'll always see whitecaps when there's a strong wind. And then the third is a breaker. A breaker is when the trough hits bottom, and the bottom, that is the bottom of the floor of the shelf or the beach, and then the crest, because the bottom hits and drags along the bottom, the crest falls forward, and so the whole wave has a breaker at the top, and so the breaker crashes forward. Now let's go ahead and try to see if we can diagram that a little bit about this breaker. So if you have a beach, let's just say the beach is of this shape, and we know it goes out, continues out into the ocean. And here's the normal water line, okay? There's the water line, or the water level, I should say. Here is the beach, okay? Now, a wave is, because of the wind pushing, a wave is coming up and down. The water traveled up and down. Now, you can see what's going to happen on this next one. The wave here begins to hit the bottom. Okay, so the bottom of the wave drags on the sand. Okay, the bottom of it drags on the sand. It encounters friction. So what happens as the bottom drags, the top of the wave, of course, continues moving through, and the top begins to curl over and crash. So the top curls over and then it crashes. It breaks up. And that's why they call them a breaker. It breaks up and it washes up and then it washes back. And you got another wave that comes in, and the bottom strikes the bottom of the wave strikes the beach, slows it down, it drags on the sand, so the bottom of the wave slows. And it slows while the top continues moving. But remember, it moves in a circle, but now what happens? That bottom is dragging. And so the top actually curls over and then breaks. And so you have this curling sensation and it breaks. And then it washes up on the beach and washes back. So you have this interesting dynamic with a breaker. So what happens with the wave action on a beach? Well, the wave action, this water that moves up on a beach and sweeps back and forth on the beach, this wave action is really responsible for erosion. We have erosion that results from this wave action, and if there's just normal conditions, not much sand moves around. It kind of moves it back and forth, but then you get some big waves or some waves that are, high wind kind of waves. They'll come and they'll move increasing amounts of sand. So the larger waves, or waves with great wind, we think of a hurricane being one of the worst things on a seacoast. So hurricanes, you're looking at winds upwards of 90 miles per hour. And when the wind's like that, and of course they've stirred the water up and they reach far up the beach, and they hit what normally isn't hit by the water, and it erodes the land. So you have a lot of erosion with a hurricane situation. We're going to go ahead and try to give you some of the parts for the worksheet. Now the worksheet is a worksheet of a wave, and I'm going to go ahead and go to part 2, and you'll have you're going to get this worksheet, and so you can fill it out as we go over it together.